Alright, so let's quickly look at this. A metal object of mass 3 kg is heated from 25 degrees Celsius to 45 degrees Celsius in 10 minutes by an electric heater rated at 70 watts. Neglecting heat loss, calculate the specific heat capacity of the metal. So let's see. Options A, 1.07 times 10 raised to the power 2 joule per kilogram per Kelvin. Option B, 4.2 times 10 raised to the power 2 joule per kilogram per Kelvin. And then option C, 7.0 times raised to the power 2 joule per kilogram per Kelvin. And finally, option D, 4.3 times 10 raised to the power 3 joule per kilograms per Kelvin. So let's see which of the options might be the correct option. So let's see. The first thing we need to do, we quickly bring out our data and then see what we have. We have mass M equal to 3 kg, alright? And then heated from 25 degrees Celsius, that is theta 1. Theta 1 is equal to 25 degrees Celsius. Theta 2 is equal to 45 degrees Celsius. Temperature change should be 45. Now is theta 1 minus, or rather theta 2 minus theta 1. Theta 2 minus theta 1, and that is 45 degrees Celsius minus 25 degrees Celsius, and this becomes the difference here. Difference in temperature, 45 minus 25 is simply 20 degrees Celsius. We shall be working with this, alright? Our solution will depend on this, not on all this, right? So this is the first step. The next one is power. Power is given as P is equal to IV, and this IV is equal to 70 watts. Alright? That's it. Are we missing anything? So we have taken, okay, time, right? Time given, T, is given as 10 minutes. Alright? 10 minutes. Okay, 10 minutes is equal to 10 times 60 seconds, and this we have as 600 seconds, right? This becomes our new time, T. Good. Now, we look for a relation that connects this, that connects heat to specific heat capacity. Of course, we are talking about heat, right? So that should be H is equal to M C and then temperature difference, right? Theta. Good. That's what it should be. Right? So when we have this, it means that from this, we are looking for specific heat capacity C. That's what we're looking for. So we can now say that H is equal to IV T. Okay? So now we have this. We can use this as equation number 1. This can be equation number 2. Heat. We're talking about heat, okay? So what is providing the heat here, or supplying the heat here, is the electric heater, right? Rated at this. So where we have H, we have IVT is equal to MC change in temperature, theta, okay? Delta theta. So we make that. We make the specific heat capacity here, the subject, it becomes C is equal to IV T, okay, over M and then delta theta. M delta theta. Good. That's it. Our delta theta is this. Okay? Alright, just check out what I have outlined. Can you see? Our data is clear. Data is the information contained in the question, right? And it's very, very clear. Alright? And then we consider that the power or heat is from the electric heater. That's this. which is equivalent to the power, right? And that is this. Time given is in 10 minutes, we converted it towards 600 seconds. And this is the relation. H is equal to MC delta theta. H, that's heat provided or supplied by the electric heater, is equal to IVT. And this IVT represents power, which is given to us as 70 watts. And then all that stands. Okay? So let's go. The next thing we need to do, we clear this and then substitute wisely. Let's see if any of the options holds. So let's go. Alright, so I have C is the place of C, then have this. IV is 70, so I have 70 there. Okay? And then T is 600 seconds, so I just have to put 600 seconds all over. And then M is still kg. Remember, M is still kg. Where is it? Look at the 3 kg. So 3 here and then times change in temperature. 45 degrees Celsius. It has been worked before. 45 degrees Celsius minus 25 degrees Celsius. And what will remain is 20. Okay? So we have this 20. And finally, we substitute 70 times this. Okay? Find this, 70 times this. That's what we're going to find. And we have 70 times 600. Let's just do that. We can say 600 times 70. Let's see what we have times 70. It's very simple. What we do here is 0 times 0 is this, times this is 6, and this is 6. Go. So 7 times 0 is 0. 7 times 0 again is 0. And then 7 times 6 is 42. 42. Good. So we have 7 times 6 is 42. And what we do, we bring down 0, and then 0 again, 2 and 4. So this is 3 times, this is 60. So we now know that this is for 42,000. 42,000. Let's cross check this, this, is this, and this, and then find this. So it's correct. So what we need to do now, we now have 42,000. We can now claim this. We have found out all that. So this becomes 42,000. Where's chalk? Okay. So this becomes 42,000. Alright. All over 3 times 20 is 60. Good. That's it. Check it very well. Let's see. Is 60? Is 60? Okay. So we can cancel this and cancel that. Good. Yeah. 6 divide itself, 1 divide 42 is 7. So we have 700. So what happens is just 700. 700 joule a kilogram a Kelvin. Right? That's it. But we can still put this in a standard form. Okay? By the time we put this in a standard form, we can have C is equal to 7.0, okay? 7.0 times 10 raised to power 2 joules per kilograms per Kelvin. Good. So let's see which option. Let's go through the options once again. That's it. So option A 1.07, no. Option B 4.2, no. Option D 4.3, not it at all. And then finally, option C 7.0 times 10 raised to power 2 joule per kilograms per Kelvin. Good. So our best option here is this. Soft. However, if you feel or if you think otherwise, comment it in the comment section. Let's further that discussion. Sign up now.